Hey there, Mr. Wilford here. I just wanted to go through Chapter 5, Section 8 with you today, curve fitting with quadratic models. Now, we've been dealing with quadratics this whole chapter, and now what we want to be able to do is take a look at some different data, some different real-life situations here where we're given information, we're given data, we're given x's and y's, a bunch of points, and what we want to be able to do is fit those points to a quadratic equation. And one way to do that is to look at the differences, the set of differences um, in data points. And what we're looking for here is, it says, for a set of ordered pairs with equally spaced x values, a quadratic function has constant non-zero second differences. So if you take a look at this right here, my x values here are equally spaced. They increase by 1. And my y values, these are really the y values. If we take, you always want to take one y value minus the previous one. So 4 minus 9, 1 minus 4, 0 minus 1, and so on. And you get these first set of differences in blue. Now those are not all constant. If they were all the same, we would say this is linear, but they're all different. So then we go through and we do this again. Minus 3 minus a negative 5 is 2. Minus 1 minus a negative 3 is 2, because we're taking minus a negative. So we have two negatives in a row. It makes it a positive. 5 minus 3 is 2, and so on. So we get these second set of differences. They're all constant. That makes this set of data quadratic, and we can fit that. We will have some problems here where you're going to have to find out, determine whether it is quadratic or not. You can see here that the second set of differences are the same, so this would be quadratic. Here you can see the second set of differences are not the same, so this would not be quadratic. Now, there are different ways that you can find the actual quadratic equation that fits these points. One way to do it is to use three quadratic equations here with three variables. You certainly can do this algebraically. It does take some time to do this depending upon what kind of points you're given. So you certainly can take these 3 points and you can plug them into this quadratic, and you can actually figure this, these a, b, and c values out. I would suggest that you actually use a quadratic regression calculator. A graphing calculator will do this. A quadratic model is a quadratic function that represents this data, so what we would want is a quadratic model for this. And your calculator, your graphing calculator will do this, and I'll actually show you one that's online that you can use. Basically what you want to do is use your stats button, and you enter in your points into L1 and L2. These would be your X's, these would be your Y's. And then you press your stat button again, and you do some calc for quadratic regression, and it will give you this result here. So this is your quadratic equation, ax squared plus bx plus c, and it gives you the a, b, c values, and then it will actually give you this this r value, which is basically how well your equation fits those points. So you can use your graphing calculator to do these problems right here. If you take a look at number 5, there's actually, I'm going to show you these points here, negative 2, 5, 0, negative 3, and 3, 0. You can use your graphing calculator, plug in those points. Or I have a graphing calculator, a regression calculator here, and I have a link to this, should be on my website in the classroom. But basically you do kind of the same thing. You enter your x's in here, your y's in here. You don't have to put anything in here. And then really all you have to do is click this button here. This is the quadratic button, and it will give you your quadratic equation that fits those points right up here. It's kind of nice because you can actually press graph, and it will give you like a scatter plot. It'll plot those 3 points and actually give you the graph of this quadratic equation. So it kind of puts it all on one page here. But this would be my answer right here. 1x squared plus, negative 2x minus 3 would be the answer. If you have any questions, please let me know. Thanks.